Okay, this is number 1 in your free response packet for slope fields and differential equations. If you haven't already read the question, pause the video, read the question, then start it again because I'm going to pick right up with starting to solve them. Just 2 parts to this question. So the second part, part B, should be looking very familiar. That's exactly what we've been doing. Solve the differential equation with the initial condition. But I am going to start with part A. Just know that part A is not something we've done in this chapter. Part A, I guess the key is right here. They're asking us to find the second derivative. So they're giving us the derivative. Good news is that normally we have to find a derivative and then find the derivative of the derivative to get the second derivative. Remember, a differential equation has a derivative in it. So we're taking that equation. I'm going to go ahead and rewrite. dy dx equals y squared times 6 minus 2x. We're taking that equation, and what we're doing is we're going to take the derivative of both sides, take the derivative of the left, and then take the derivative of the right side. And I don't think I need anything else from there. So on the left side, that gives me the second derivative when I take the derivative of the derivative. And on the right side, we should be looking at that and noticing that, first of all, there's 2 variables, an x and a y. So we should be thinking implicit differentiation right now. And then we also need to be thinking product rule. I've got one function, and then I've got a second function there, the 6 minus 2x. So I am thinking product rule, good review. We haven't done this for a while. So let's go ahead and walk through this one, or pause the video, try it, and then check. Product rule, I'm thinking first function times the derivative of the second. So that would be y squared times derivative of 6 minus 2x is going to be just a negative 2. Plus second function, so now it's the entire 6 minus 2x, times derivative of the first function. Derivative of that first function is 2y, but you're not done yet. When we're doing implicit differentiation, we have to follow it by dy dx, unless we have an x. So if it's any other variable, because we're differentiating with respect to x, we have to multiply it by that differential dy dx. So that's your setup for the second derivative. But recall when we were doing implicit differentiation, like I said, it's been a while. When we're doing implicit differentiation, we never want to leave a derivative in an equation. So we do need to replace this dy dx with what we know dy dx is. Go back to your original equation. And I know mine looks a little bit messy right here, but it's this part right here, or it's right up here. That's what's getting plugged in for my dy dx. I can also tidy things up a little bit, so I'm going to go ahead and do that as I rewrite. I'm going to end up with second derivative equal to negative 2y squared. And then I've got, I don't think I'm actually going to do anything on the right side yet. I'm just going to go ahead and make my substitution. So I'm just going to keep it as 6 minus 2x times 2y times dy dx, which, like I said, is y squared. I'm looking at the top there. Y squared times 6 minus 2x is my dy dx. Whoops. So from there, you have a couple options. The actual question is asking, we can simplify, but the question is asking for us to find the second derivative evaluated at the point 3 1/4, 3 comma 1/4. So before you do too much work trying to simplify everything here, remember you're just plugging something in. So I would probably go one step, and what I'm noticing is that we have a 6 minus 2x, and this is just going to make it a little easier when I plug in. 6 minus 2x, I have that quantity twice. And then I also have a y and a y squared. So sure, I could do a little bit of simplifying here. And I would probably take it to here. Negative 2y squared plus 2y cubed, which I'm getting from right here, times the quantity 6 minus 2x squared. And that just looks a little bit better to me. Now I'm going to go ahead and substitute in. So I'm evaluating that at the point 3, 1/4. A lot of times it's written this way. And that vertical bar just indicates evaluated at. It's supposed to be a 4. So that would be me now going through and substituting in. For every y, I'm going to be putting a 1/4. So that would be right here and here. And then whenever I see x, I'm going to be putting a 3. So the 3 is going to go in right here. Right away, I'm looking at this as 6 minus 2 times 3. 6 minus 6, that's going to be a 0. So if you're thinking, wow, this is looking really ugly, things are going to cancel out and it's not going to be too bad. I'm going to let you finish up that part. I think you can do that. That was a good review of implicit differentiation. Good example of how they're taking two completely different concepts and putting them together. In terms of when we've learned them, you'll see that a lot on the free response questions. So there was the implicit differentiation part from first part of calculus, differential part of calculus, or finding derivatives. Second part, B, now we're going to go with what we've been practicing, which is solve the differential equation, and ultimately we're going to be doing an antiderivative. So part B, I'm going to grab that equation, and instead of taking the derivative, I'm going to try to find the solution or the equation, y equals something, that satisfies an initial condition that they're giving me. Okay, notice that we want to know what equation would pass through that same coordinate point. So, a new page. So my differential equation dy dx equals y squared times 6 minus 2x. First thing I need to do is separate my variables. So I need to put my y on the left and keep my x's on the right. I've got a product right now. Those two things are being multiplied together, y squared and 6 minus 2x. So I'm going to divide by y squared, and I'm going to divide by y squared on the left, but I like to write that as times 1 over y squared. Same thing mathematically, but it looks a little bit better to me. So I have 1 over y squared dy equals, those cancel, so I've got 6 minus 2x on the right-hand side. And I sort of ignored that dx. I still have a dx here, but I ultimately want to get rid of that. So next step is going to be, let's multiply by dx on both sides, and it cancels there. I've got 1 over y squared dy equal to 6 minus 2x dx. So now I have separated my variables. Just for your information, that is a point right there on the AP test when they're grading it. 1 point for separating your variables. Next up, I want to get an equation for y. So I need to take the antiderivative of both sides, or evaluate the integral is another way of saying that. So if I take the integral of the left side, I'm thinking, and this one's going to be a little bit tricky, I'm thinking, what's the antiderivative of y squared? So I'm going to kind of go over here and do a little bit of thinking backwards, if you will. Y squared in the denominator is really y to the negative second. I want to get that. So I'm thinking that I have to start with a negative first power, because when I subtract a power, then I'll end up with a negative second if I take the derivative. But I'm actually going to end up with a negative y to the negative second, so I'm going to put a negative in front there. And now if I take the derivative of that, negative times negative 1, because I dropped my power out front, gives me a positive y to the negative second, since I'm subtracting a power from here to here. So my antiderivative is this. I'm going to write it, though, as negative 1 over y instead of y to the negative first. And then remember, I do have a plus c there. I'm going to ignore the plus c because at the end I'm going to have a plus c on the other side. So you could write it there, but as long as I have a constant in there, then I'm fine. So I've got negative 1 over y is equal to, and I've got to do the antiderivative of the right side. Antiderivative of the right side is not so bad. You're much more comfortable with this. So as long as you remember that you're going backwards, we should be getting 6x minus 2x squared over 2. 2's are going to cancel, and then I'm going to have the plus c here. That would be points, just if you're keeping track of your points. Point right here and point right here. Point for constant of integration. So that step actually got you 3 points. this was the other point. 4 points. This would be a 6-point part, and this is unusual that one part of a free response question will be so many points. So, good thing to make sure that we can do, because we are going to get a lot of points for it. Okay, from here, I want to solve for y, but I also want to satisfy an initial condition. So you have two choices. You could go ahead and substitute in right now the coordinate point that they have, the initial condition, f of 3 equals 1/4. So that's going back to the question. They told us f of 3 equals 1/4. That's really saying that this curve, whatever I have, has to pass through the coordinate point 3 1/4. I could substitute that in, or I could solve for c. I don't know that there's a better or a worse here in terms of how you do it. So let's go ahead and substitute it in and get c. So I've got negative 1 over y is 1/4 equals 6 times 3 minus 3 squared plus c. Negative 1 over 1/4, that looks a little ugly, but that's really just negative 4. 18 minus 9 plus c. And I'm getting, I don't know why that won't move. It's making me angry. I'm getting a 9 plus c on the right. Negative 4 equals 9 plus c. Subtract my 9, so c is negative 13. Go back, and I need to take this equation, substitute my c in that I now know. I don't need to worry about that because I really just need to know that I have one constant. And then I need to solve for y. So I'm going to rewrite that just because I'm out of room here. Negative 1 over y equals 6x minus x squared. And then minus 13 because I'm putting in the c that I just got. That was my plus c a minute ago. So to solve for y, a little bit awkward here because my y is in the denominator. I need my y in the numerator. So there's a couple ways that you could think of this. I suppose the easiest for me is probably just to make this side a fraction, because if I have two fractions, I'm really looking at a proportion and I'm cross multiplying. Or you may remember that you can flip it as long as you flip both sides. So ultimately, you're going to get negative y equals 1 over 6x minus x squared minus 13. And I would get rid of the negative and put it on the other side. I'm going to show you real quick how I could get to that a different way. If you're not okay with just flipping it, then let's go ahead and cross multiply. So I'm going to take my cross product literally of this times this. So I'm going to have y times 6x minus x squared minus 13 equals cross product on the other side. Not interesting, 1 times 1, but I have to note that it's 1. And I want to solve for y. So at this point, divide by everything. 6x, whoops, I missed a negative here. Sorry, going back real quick, I had a negative 1 times 1, so that's going to be a negative 1 here. 6x minus x squared minus 13, divide by that on both sides. Cancels there, and that's getting me, obviously, what I have right here. So at this point, I already have the negative on the right side in my step up here. I would just be multiplying by a negative 1 or dividing by a negative 1, whatever you want to think of it as. Here, times 1 over negative 1 is a good way to think of it, to make those positive. So I've got y equals 1 over distributing a negative to my entire denominator. I'm also going to switch things around in terms of order. I'm going to put my x squared term first, but remember that's going to be a positive now because I'm distributing the negative. So x squared minus 6x plus 13. So this negative made this go to negative, that positive, this positive, and the only thing I did is rearrange things slightly when I put them down there. So that would be my equation, and there would be your 6th point. You would have gotten a point for solving for the 13 using the initial condition, and then your final point, point 6, would have been to get to here. Okay, hopefully that helps. I would try number 2 is easier, so go ahead and try number 2 right now, and I think you'll be totally fine with that one. Also, make sure you finished up part A. I didn't finish part A on this one.